and welcome to the second video in my chemistry series. So today we're going to be talking about Sig Figs. Sig Figs are quite annoying, but unfortunately they are going to be a part of pretty much every calculation you make in chemistry. So I'm going to show you today a more simple way to do them instead of having to remember the long list of rules. Here is a very simple method for remembering how to find the number of Sig Figs in any number. So there's two possible cases we could be dealing with. There could be a decimal point or there could not be a decimal point. So first let's look at a number that does have a decimal point. So let's consider 0.021. And so now we have to find how many Sig Figs are in this number. So since it does have a decimal point, we're going to start from left to right. So starting from the left side of the number, we want to count all the way until we reach our first non-zero digit. So our first non-zero digit here is going to be this 2. So we start counting Sig Figs from there up until the very end of the number. So here we have 2 and 1. So there's 2 Sig Figs in 0.021. But if there was more digits on this side, even if they were zeros, those would all be counted as significant figures, because you start counting from the first non-zero digit all the way to the end of the number. So this is going to have 2 Sig Figs. And now let's look at the case in which we do not have a decimal point. So we're going to consider the number 312,000. And this number does not have a decimal point. So instead of starting from the left side of the number, we are instead going to start from the right side of the number and count. So these are all zeros, we ignore them. We find our first non-zero digit, and that is going to be this 2. So this 2. And then we count every digit from that digit onwards as being a Sig Fig. So we have 1, 2, 3 Sig Figs in this number. So, as we can see from these two examples, the generic rule is going to be when you have a decimal point, start counting from the left and find your first non-zero digit and count everything after that as a Sig Fig. When you do not have a decimal point, you're going to start from the right side and you're going to go backwards, find your first non-zero digit and count everything including that and after that as Sig Figs. Now we have one more consideration. What if we are dealing with a number that's in scientific notation, which we will encounter a lot in chemistry? So let's look at the number 3.20 times 10 to the negative 6. So when you're dealing with a number in scientific notation and trying to find the number of Sig Figs, you can pretty much ignore this part. You can ignore the 10 to the power of whatever part and just focus on the actual base number. And the number of Sig Figs that are in this base number is going to be the same as the number of Sig Figs in the total number. So we're just here going to be looking at 3.20. And we can see that this number here does have a decimal point, so we're going to start from the left side. And the first digit, 3, is your first non-zero digit, so we're going to count every single digit as a Sig Fig. So we have 1, 2, 3. We have 3 Sig Figs in this number. So now that we know how to actually find the number of Sig Figs in an individual number, let's think about how to do some arithmetic operations with Sig Figs. So for addition and subtraction, we have one set of rules for Sig Figs. So let's look at an example problem. What if we are adding 3 plus 2.6? So if you were going to do this addition problem just normally with no Sig Figs involved, this would be equal to 5.6. But now when we have Sig Figs, the rule for addition and subtraction is that we are going to give the answer rounded to the same number of decimal places as the number with the least number of decimal places out of all the numbers you're adding. So since we're only adding 2 numbers, the least number of decimal places is going to be 3 since it doesn't have any decimal places. So that means we have to round this 5.6 to the same number of decimal places as the 3, because we cannot express more certainty in the answer than we have certainty in the things that we're adding. So we're going to have to round this up to 6 in order to have an answer that's expressed with the proper number of sig figs. And then we also have some rules for multiplication and division. So suppose we were multiplying 3 times 2.6. This, just done with no sig figs involved, would be equal to 7.8. So now let's look at the sig figs. So for multiplication and division, the rule is that we're going to have in the answer the same number of sig figs as the number with the least number of sig figs. So for multiplication and division, you're looking at sig figs. For addition and subtraction, you're looking at decimal places. And sometimes those are the same thing, but sometimes they're not. So remember those two rules, they are different from each other. So we look at the 3. This is pretty obviously has only one sig fig. And here we look at this 2.6, and this has a decimal point, so we're going to start from the left and count 1, 2 sig figs. So 1 is less than 2, right? So we have to have our answer expressed in only one sig fig. And this currently has 2 sig figs, so we're going to have to round this to 8 as the answer expressed with the correct number of sig figs. And that is all for our sig figs tutorial. I hope it was useful to you guys. Make sure to see me next time for some more chemistry videos.